Good afternoon, YouTubers. Let me do something here very quickly. Um, this is an animation for a double acting steam engine. And the reason why I did this was because somebody asked me about the timing. How is the timing in a double acting configuration system? And I did some drawings in a piece of paper. And after the second drawing, I realized that this is going to be too complicated to talk about. I mean, you can definitely do more drawing. At least you need four of those by hand. But I said it's a lot easier if you see it, how it works, and how is the relationship between uh, the valve and the power piston. So as you can see, this design is turning counterclockwise, and so I skip many parts like the axles, the connection, and so forth, just to make this as simple as possible. And obviously there's a line, and either you can call it, oops, let's go the other way. There's air line or steam line between this notch here, this cutoff, and this. So and there's also a notch here and here, so there's a line. Imagine that there's a line here that can connect, and air can get in here. I'm looking this more to be more like either steam or air engine type. Is the same, as long as you put something with pressure here. This gap will connect with this gap, and this gap here will connect with this, and this is the body of the valve, and this is the power piston down here. So let's stop this animation for 1 second, and let's go on it smoothly, slowly, so you can see what's going on. Right now the power piston is right at the bottom of his trouble, and the only thing that can happen here is that air need to go this way, or steam need to go in here, so to push the piston down. As the piston is going down, this gap here, air need to escape, or steam, whatever is here, drop it, needs to escape and to the environment. So basically, if I keep turning this guy counterclockwise, you see, like for example there, just a little bit. Now if there's steam going in here, that steam will be allowed to go through this gap into this one here. So air or steam will go in here and push the piston down. See? On the other hand, as you can see, this block that was kind of covering the cutoff on the body of the valve now is open, so whatever is trapped here, air or steam, will come out this way. So you keep doing your counterclockwise until you are pretty much at full way. This part here, air or steam will come out easily through this opening here. On the other hand, whatever is coming in like steam is easy getting here, so rushing in until you keep going, and now at one point, there we go, everything is closed, and now this is a steam that is coming in here, is trapped within the middle between these two blocks, and it will not be allow us to either in through this side of the power piston or through this side. However, as soon as I start to get out of that position, you can see that now there's a gap here, and that little gap allows steam to go into this side of the power piston. So now the piston will be pushed down, and whatever is trapped here will start to come out through this connection, out. So if I keep rotating this until you get to maximum position, again fully open, whatever is trapped here is just getting out, and whatever is here is getting in through this side, through this side, through this side, pushing the piston, the power piston down. All right, so now check between this guy, this guy and this guy. So if I put this a little bit right there, more or less, you are about, there's a 90 degrees always between the flywheel or the position of this rod versus the power piston. That is 90 degrees in advance of the position of the valve. This is where the valve is located, and here is where the power piston is located. So as soon as I rotate this a little bit more, I'm about bottom line. You see, right now is bottom. This is kind of left behind, but now pretty much everything start to close. This is about a little bit more. There we go. So now they're both closed, and what we need to do is allow steam to get into this side, and to do that you gotta move a little bit more, and that will allow the cycle to repeat itself. And this is it. This is how a double acting piston will work. And let's see, let's animate this. One interesting, between this and this, I have one of these motion link, so that allows me to synchronize between both of them. Now this one has the right direction going that way. Now if you animate this go in this direction, so that would be the wrong direction. The correct direction is counterclockwise, as I told you. Now let's animate this for 1 second, and that's the right movement. You can see, as long as this is down, when the power piston is to the bottom, this connection open, because this connect with this one, and it worked perfect. That's how it should look like right now. That's doing the right thing. And the other obviously is the reverse process. Now if I rotate this clockwise, let's see, get out of here, let's animate these. Let's see, not that one, this one, animate that. Now I'm totally going the wrong direction. That would not work at all. We can see in a second. Actually, let's do this by hand, so you know what I'm talking about. Right now what's gonna happen is, if I move this back, you can see that steam is getting through here, this port, into this port, into here, and now you are compressing steam, and that would not work at all, because there's a lot of pressure on this side, very little pressure on this side, because this side is open to the atmosphere. So clockwise is not gonna make it at all. This would not be able to rotate clockwise. So again, if I do the animation with this guy, it's turning totally the wrong direction. That would not work at all. The one that I need to do it is with this one, which is had the flag in the proper direction. That's how it works. So I hope this clarified better those questions about double acting steam engine. It could be a single, I mean, this could be used as a single acting steam engine. So you don't connect one of them and that's it. So for a single steam engine, you realize a lot more into the flywheel inertia to get you going and complete the cycle. But this is basically it. It is not to scale, but it gives you a good idea of how you will do your design as long as you understand the relationship. One last thing you want to, just to be sure that you get that clear. Let's escape from here. Let's get this and let's open this big. The distance from the center of the timing valve from here to here, that's that distance for the pin is basically the distance between here and here multiplied by 2. So this radius here is basically the distance between here and here, or here and here multiplied by 2. So you get the proper position. Now the gap here, or the cutoff or the pore, is basically the same size of the block here, to ensure that it's air is block or steam is block or whatever, like this and this and this and this, they are the same size basically. All right, so again, that will do. This was anime model, and we are back to business. Does look good. Let's see, there's not much to it. Remember that this port connect with this. There's a host connection or between this and this. I mean, these two pieces sometimes are one body. Like this, the body of the valve is also the body of the piston. Kind of they're together, and so this is how they are made. But again, I just did it like this, so it's more clear for you what's going on. Again, really appreciate you taking your time to watch this video about double acting steam valve timing. And as always, have a great day, whatever be your final destination. Bye.